Hello. Awesome. Hi, guys. Welcome to today's mob. I'm Getty. We have Sigu and Kevin. Linda, I'm not sure if she's going to join us, maybe later. Yeah, today we're still moving on the same book, When the Grounded Rubies. I'm looking for it right now, then I'll share my screen. Desktop, G, Ruby, there. So let me share my screen. There. Awesome. So last time we had an overview of what global scope and global variables. We saw how variables are valid through different scopes, yeah, and stuff like that. So today we're going to be looking at what we here pros and cons. Yeah, the pros and the cons of global variables. So I'm trying to remember how global variables had a dollar sign at the start, like this. Yeah, we can. Yeah, they look like money. So I can just read this. A good place to see descriptions of all the built-in global variables you're likely to need, and then some. Okay, is the English.rb in your Ruby installation. This file provides less cryptic names of the notoriously cryptic global variables. Don't blame Ruby for the names. Most of them came from shell languages and or Perl and Awk. Those are languages. If you want to use the slightly friendlier names in your programs, you can do require English, after which you can refer to that ignore case. This is also a global variable, I assume. Huh? Instead of, yeah. Instead of this. Oh, okay. Wait, what? Yeah. After which you can refer to this instead of this. Dollar sign equals, and this instead of dollar sign, okay, and so forth. A few globals have their English language names preloaded. You can say load path instead of this, even without loading English.rb. Okay, this. Yes, the dollar equals. Okay. I'm going to repeat to get. Where is it? Dollar. What's that? What does dollar equal? It's like that. We're not even in. I was going there and I felt threatened. Dollar. Is that? What did they say this does? Yeah. Where is it? You can, oh, yeah, the load path, and then there's this. What does that give? The ID. And there's this. Or PID. No longer effective. Okay, so it's for an older version or. Sorry? Yeah. Awesome. Okay. So we have the pros and the cons of global variables. Globals appear to solve lots of design problems. You don't have to worry about scope and multiple classes. Can share information by stashing it in globals rather than designing objects that have to be queried with method calls. I don't get that. Globals appear to solve lots of design problems. You don't have to worry about scope or and multiple cases. And multiple cases can share information by stashing it in globals rather than designing objects that have to be queried with method calls. Without doubt, global variables have a certain allure, I think, allure. But they they're used very little by experienced. I can hear myself echo. I don't know, but they're used very little by experienced programmers. The reason for avoiding them is similar to the reasons they're tempting. Using global variables tend to end up being substitute for solid, flexible program designs rather than contributing to it. So they end up being a substitute for solid, flexible program design rather than contributing to it. So one of the main points of object-oriented programming is that data and actions are encapsulated in objects. You're supposed to have to query objects for information and to request that they perform actions. I think we're okay. Are we still okay? Okay. And objects are supposed to have a certain privacy. When you ask an object to do something, you're not supposed to care what the object does internally to get the job done. Even if you yourself wrote the code for the object's methods, when you send the object a message, you treat the object as a black box that works behind the scenes and provides a response. Global variables distort the landscape by providing a layer of information shared by every object. They distort the landscape by providing a layer of information shared by every object in that context. What does that mean? Shared by every object in every context. They distort the landscape.
It's like it's just saying that whatever information global variables provide is available to any scope that we have. It's not the landscape. When they talk about the landscape, it's probably referring to the objects and sending messages and the likes, and the encapsulations. So distorting the landscape simply means it's not following that what just described in the previous paragraph. It is not following that.
Okay. All right. Thank you. Here's an example. A rewrite of our earlier person class, the one with the first, optional, middle, and last names. This time, instead of attributes on the object, we'll generate the whole name from globals. Okay, we have a class person, and then we have a method, called whole name. And then we have a first name variable, a global variable first name, and then it's being concatenated with an empty string with a space actually. And then we are appending a middle name, which is also a global variable, to the first name if the global variable exists. And then we're also appending the last name. Yeah. So to use this class and to get a whole name from the instance of it, you'd have to do this. First, we have to create a new instance of the person class. And then we have to, we're assigning it's called what? The variable, the global variable we're assigning David to the global variable, Alan to the middle name, and Black to the last name. And then we put David.wholename. So I expect it to have, I'm expecting it to have what? David.wholename. It should have the first name, the middle name, and the last name. So it should be David Alan Black, if I'm not wrong. We can try this on the IRB. Is it going to copy this? How does this work? So tuone venye inakaa kwa GED. Yeah. This looks a mess. Yeah. And we have that. We don't need that. We copy it
Take
away.
the definition.
Oh,
The class.
the full name. Yeah. And person. I think that's okay now. Control Shift V. Yeah. So we can now create a new instance of the person class. New. We have that, and then we set the first name, the middle name, and the last name. So it's going to be something like this. Last middle.
Yeah. Yeah.
And the last name.
Yeah. What's up?
Following order. Okay, and then we call T dot full name. So are we on the same page? It's going to read Kevin Giant Santos. Yeah. Thank you. Call whole name again. It'll just be Kevin Giant Santos. Okay. There. Okay, the version still derives the whole name from outside by querying the object, but the components of the name are handed around over the heads of the objects, so to speak, in a separate network of global variables. What did I just read? The version still drives the whole name from outside by querying the object, but the components of the name are handed around over the heads of the objects, so to speak, in a separate network of global variables. So global variables.
So to speak, comma.
Yeah.
The components are handed around over the heads of the objects in a separate network of global variables.
Okay. It's concise and easy, but it's also drastically limited. What would happen if you had lots of person objects, or if you wanted to save a person object, include its various names to a database? Your code will quickly become tangled, to say at least. So the way Kevin was suggesting, we should use another instance. So for example, we wanted that instance to have different names than the ones that have been declared for the global variables. It will be hard because global variables have to retain their values. So globally, scoped data is fundamental in conflict with the object-oriented philosophy of knowing objects with abilities and then getting things done by sending requests to those objects. Some Ruby programmers work for years and never use a single global variable, except perhaps a few of the built-in ones. That may or may not end up being your experience, but it's not a bad target to aim for. Now that we've finished with the try not to do this part. That's what it was called. Let's move on to a detailed consideration of local scope. So we have the local scope. Local scope. I'm thinking local scope. Are they talking about local variables or
Scope.
is a
I
basic
think
layer?
it's explained.
Yeah, is a basic layer of the fabric of every Ruby program. At any given moment, your program is in a particular local scope. The main thing that changes from one local scope to another is your supply of local variables. When you leave a local scope by returning from a method call or by doing something that triggers a new local scope, you get a new supply. Even if you've assigned to a local variable x in one scope, you can assign to a new x or in a new scope, and the two x's won't interfere with each other. Okay, you can tell by looking at Ruby program where the local scopes begin and end based on a few rules. So the top level outside of definition blocks has its own local scope. So top level is a scope on its own. Every class or module or definition block has its own scope. Even nested classes and module definition blocks have their own scope. And then thirdly, there's every method definition has its own local scope. More precisely, every call to a method generates a new local scope, with all local variables reset to an undefined state. Does that make sense?
Undefined local variable
Yeah.
x.
So exceptions and additions to these rules exist, but they are fairly new and don't concern us right now. Oh, there are fairly few and don't concern us right now. So figure 5.2, the table, illustrates the creation of a number of local scopes. Every time you cross into a class or a module or a method definition block, every time you step over a class, module, or def keyword, you start a new local scope. That's clear enough. Okay, so we declaring a variable on top level. Top level is anything that is outside of a block. So we're declaring a variable a and it's assigning 0 to it. And then we have a method definition that's also on top level. It's called t, and it puts top level method t. You see? Um, let me go to this arrow. So there's this arrow that's pointing here and then coming down to point out here. It says top level outer scope. The same way I've explained, when we talk about top level, it's outside of any block. So we have a class C. In class C, we also declaring a variable A that has the same name as the one outside of that scope. And we're assigning it to 1. And then we have a method called self.x, which is, say, a class. No, it's not a class method. It's a singleton method. And then inside it, we also have a, which is equal to 2, and we put this. Inside it, we also have a method definition m, and we have declared a also. The same with n has a that. So all these methods are within a scope that is the class C. Classes we've seen are also scopes. Whenever you begin a class or a module or a method definition, you're only beginning a new scope. This method is also a scope on its own. This method is a scope on its own. This method is a scope on its own. Okay. And then at the end of all this, you also put in class this. So which what am I saying? Oh, this, the top level A, this. What do you think is going to be the value here, Kevin or CP? 0 minus 0.
Why are you subtracting? Why are you subtracting? For you, not subtracting. You get the value.
Yeah. Oh, so it's, yeah, it's 0.
The second one, the first one that you started with.
Which one? This?
No, who's class A? Not that.
But where are
No,
we?
the third then.
This one.
Yes.
Okay.
No,
This
not
one.
that.
This. Or this one. The class scope A equals A. A in this case is what? A in this case is 1.
It should be 1.
Yeah. You okay? Okay. So, variables that lie very close to each other physically may in fact have nothing whatsoever to do with each other, as this example shows. So we have a variable A, we have another one inside the definition block A, we have, and then we put in A inside the block, the method I mean, and also outside the method inside the class. So they're saying they might have nothing to do with each other since they declared under different scopes. But okay, that makes sense. Okay. So this code produces the following output. So if we create a new instance of C, here's our class C, and we call local A on it, it produces 1 and then 2. So it's going to produce this first and then this.
But that's
Oh yeah.
Oh yeah, I understand. I know.
1 and 2. Why? Why isn't it starting with 2?
How do you make number? How do you execute number 3? Like not really, whatever zero numbers. Yeah.
Once you, when you refinish the class definition,
When you finish.
the class definition is
Okay. And how do you call the second one?
you call the method
Okay, so which one comes first?
the class one.
The
Class.
yeah. It calls with
Okay, thank you. All right, the variable that gets initialized in this local scope of the class definition is in a different scope than the variable A inside the method definition. When you get to the puts a statement after the method definition, you're back in the class definition. Oh, I'm reading it as A. When you get to the puts A statement after the method definition, you are back in the class definition local scope. The A that gets printed in is the A you initialize back at the top, not the A that is in the scope in the method definition. Meanwhile, the second A isn't printed until later when you've created the instance of C and sent the message local A to it. Or just the exact thing you were saying. When you nest classes and modules, every crossing. What's this? When you nest classes and modules, every crossing into a new definition block creates a new local scope. The following listing shows some deep nesting of classes and modules with a number of variables called a being with a number of variables called a being I keep saying the number of variables called A being initialized and printed out along the way. Okay, so there's this deep nesting thing going on here. We have a class C, a module M, module N, class D, and then we have a method, and all of them have a declaration of A, of the variable A. So that just, it's different scopes having the same name of the variable. Yeah. So what now? So in order for us to create an instance of the class D, we have to nest all the way from C, M, N, and D. So every definition block, whether for a class, a module, or a method, starts with a new local scope, a new local variable, scratchpad, and gets its own variable A. This example also illustrates the fact that all the coding class and module definition blocks get executed first, and whereas methods aren't executed until an object appropriate message. That makes sense. So that's why the value of that A that's set inside the show A method is displayed last among the 5 values that the program prints. The other 4 are executed as they are encountered in the class or module definitions.
I lose concentration.
Why? Because you were talking.
No, because we are reading.
Sorry?
Because we are reading.
I don't follow.
I'll never speak.
Oh.
After every statement, how goes.
Every definition block or a module or a method starts a new local scope, a new local variable, scratchpad, and gets its own variable A. Hadi hapo mko sawa?
I will try by
This. Okay, we have that.
explain that.
So we have a class C, and the class C contains a module M. It has a declaration A equals 5. It has a module M, which also has a declaration of A equals 4. We have a module N, which has a declaration of A equals 3. And we have a class D, which has a declaration of A equals 2. We also have a method show A, which is inside the class D, that says A equals 1. And for every scope, we're putting
Now we
A.
put in the reverse order.
Sorry?
We now put in the reverse order.
Yeah. Okay, so I'm going to end that. So it prints 2, then 3, then 4, then 5. So it starts from this first, and then this, and then this, and then this, because the puts we're putting from the first class, which is D, and then N, and then M, and then C. So that's why we have this. But for us to get the A that is in the show A method, we have to call an instance of D first, and then call to it this method. So that's what we're going to do. So we have variable, and we do. I'm just putting it there. It's not a must. So we have C. We have N. We have. Oh, sorry. Then we have N.
What happens if we tap?
Tab.
Tap.
Then we have D. What was next? That was the last one. But new. Yeah. So only at this point can we call what? Can we call the method? I don't even remember. Show A. So that show A. So we get 1 because A at that specific scope was 1. Is that okay? Next. Where were we? This example also illustrates the fact that all code in class and module definition blocks gets executed when it's first encountered, whereas methods aren't executed until it is sent the appropriate message.
Assumption.
Yeah, that's fine. So that's why the value of A that is set inside the show A method is is displayed last among the 5 values that the program prints. The other 4 are executed as they are encountered in the class or module definitions. But the last one isn't executed until show A is executed by the object D. It's just the same thing that we were saying before. So local scope changes often. As you can see, so does the identity of self. Sometimes, but only sometimes, they vary together. Let's look at a little closer at the relationship between scope and self. Okay. Kevin, so you can take over from here. Yeah, thank you.
Okay. Okay. So let's see the interaction between local scope and self. So when you start a local scope, or when you start a definition block, you start a new scope or a new local scope. So if you have a method definition, you have started another local scope. If you have a module definition or a class definition, you have started a local scope. So you start a new local scope, and you also create a block of code with a particular self. So meaning if we maybe defined a class method, yes, it's a local scope we have changed into, but the self in that case will be the class. If it was an instance method, we have started a local scope, but the particular self at that point is now an instance of the class. But local scope and self don't operate entirely in parallel. So not only because they are not the same thing, but also because they are not the same kind of thing. They are not the same thing, but they are not the same kind of thing. So, yeah, we have a listing here. We have a listing here that uses recursion. As in the instance method calls itself. So when you define, we have defined a method, an instance method, which within it, as it executes, it will call itself at some point. So the point is to demonstrate that every time a method is called, even if a previous call to the method is still in the process of running, a new local scope is generated. Yeah. So we have a class C. Then we have Then we have an instance method X in it that has the arguments value for A and recurse false. So if you want if you want the recursion to occur, probably set it to true. Yeah. If you don't want it to occur, you can. It will not, by default, it will be false. Yeah. So at this point, we have our variable A, which is just the value of A. Then print here is the inspect string for self. Then at this point, we are now printing self, which at this point, being that X is an instance method, it will be the object on which we will be calling X on. Then we are then outputting, and here is A. So at this point, A is local. The value will give it this, yeah. Then we are now saying if recurse. So now recurse is true. We then calling myself. Then now at this point now X is calling itself. X is calling itself and we are passing it a second value. So at this point, X has called itself. Now it creates because we have it creates now a new local scope at this point. So at this point, our A is second value for A. Yeah? At this point, A is second value for A. Then, okay. Yeah, then back after the recursion, here is A. So this A here, I think I should, let me first copy this. Will it work? Okay, up to there. Oh man. Okay. Then yeah. Then now let me, this should be end. Let's see, bring it this side. Oh, this is IRB. Oh shit. I don't know if it's that. So this is our class C. Then we have our method, our instance method X. So at this point, if I create an instance of C, then call, okay, let me just then call our instance method X. Then I give it a value, let me say getty. Let me, yeah, this way. What will happen at this point? Then the print self to be that object. Yeah. Then and here is A. Then it puts A, which is get. Then we don't have recurse, so it will not recurse. Yeah. So that is it, and there's get. So if now we wanted, let me use, okay, another instance, call X on it. Then now recursive or recursion at this point is true. So I'm expecting at this point the value of A, which is SIG. Then here's the inspecting self is that object. A will print SIG, yeah. Then our we have set recurse to true, so it will come at this point, calling myself, print that. Then calls itself. Now X calls itself, but this time the value is the second value for A. So the value of A at this point is second value for A. Then yeah, it should start from A equal. Yeah, I think execution should start from the top. Then when it comes here, so first it will print out Sigu. Then if it comes here, it finds recurse is true, prints that, sees that X has called itself, and this time given it self, the argument second value for A. Then prints back after recursion here is A. So at this point now A is second value for A. Then exits, meaning goes back to resumes or exits this scope and continues and finds nothing, then exits. Yeah. So where is it? Where is it? Where is it? So I start here is that prints here is a sigu calling myself. Here is yeah, same self, and here is A. And here is A. Now that the time X calls itself, it like starts from now. When X calls itself with the value second value 4, so it will like come to, when it calls itself, it will come here. Yeah? So A here is second value for A, which we have. So it will first print here is that. Then self, yeah, which is this. Then A, which is second value for A. Second value for A. Yeah, then back after recursion. Oh, this scope, we have exited this method, this scope. Then at this point, we have exited the scope, the method definition. So this A should be the one we passed here when we were so at this point, at line, okay, whatever that line, at this point, or let me just repeat how it will go. So the first thing will be printed will be this, yeah. Then self, which is that object you're calling it on. Then A, which when we were calling X, A is Sigu, yeah, prints out Sigu. Then this is now, yeah, the first, let me say the first execution of X. Now recursion is true at this point. So now X calls itself again. So it will print out calling myself. Then here is X. So it will like follow this same procedure here, setting A, which is value of A, which is second value, yeah. So immediately after Sigu, we'll have calling myself. Then now our A is calling myself, yeah. No, not calling myself. Our A is second value for A. So self is still that object, and here is A. So A at this point, it will now print second value for A. After that, the method exits. That we are finished. X has finished its execution at that point. Yeah, so now we exit back after the recursion. Then here is A. Now this A, we are now back to our local scope here. And the A we gave is Sigu. Yeah. Any questions? Gary? After, so if you set recursion to true, okay, so let me do another one. Let me say key. So if we only do this, we just go back to the way method lookup will go, yeah? Finds if this, we have the class C, which is an instance method. Then it comes and sees that the instance method takes a value for A, which you have given the first argument, and recurse by default is false, yeah? So at this point, if we don't give it, this is we usually have variables. We usually have optional. No, not yeah, parameters. We also have optional. We usually have default parameters, optional and required. So this one is default. Required is value for A. This one is default. So if you this is the default, then you can give it another, yeah. So at this point, we only have value for A, then recurse at this point is false. So the way that will go is at A we have G, then we'll print here is that self whatever that is, okay. Then self, print out self, and here is A, which is G. Okay, then after that finds recurse is false. So this doesn't execute. Then we exit. So we'll have that here. We'll have this. So can you assume every method call has its scope? We are not assuming, huh? Can you assume that every method call has its scope? Yeah. It's local scope. For every call we have a local scope. So what you've just done right now, put a local scope because we called X. We have only called it once, yeah. So when you call it once, it creates a scope where A is valid. That call only. Yeah, so if you let's say in there, then true. So meaning this point X will call itself the first time, then the second time. So we call it, yeah, then it calls itself. So the first time that's there is the first local scope it gets. When it calls itself, it creates another local scope. When it exits, it comes back to now there, yeah. So from this, can you maybe interpret the output for this? Can I scroll? Mm-hmm. Awesome. Okay. I think that's let's see what they're saying here. So the instance method X takes two arguments, a value to assign to the variable A and a flag telling the method whether to call itself. Mm-hmm.
I've been thinking about us. But no. Okay, I was thinking about this global variable thing. So let's say we have control. Controller is a name that not all people call it. So let's say embody your controller. Then it's the same you. Then we send you home. Okay? You've forgotten something at home, maybe Mrs. Charger. You forget it at home, then you go back to pick it. So you are here, you are playing with controller. You go home, you being the same person, they start calling you giant. Whatever it is you're doing there, you're a giant. Okay? When you come back, you're still controller. Now that you're back to where you are. We sent you out to do whatever you're doing. You pick up a different name. Then when you come back here, you are once again
I go back to my default
controller.
or original.
Yeah, so if you go out to represent, maybe you're in an event, you might say you're a marketer. So at that point, you're a marketer. When you come back here, you're still a controller. I don't know whether that's the best example.
Yeah, makes sense. It's a good. Yeah, thank you, Sigo. Okay. So the use of the flag provides a way to prevent infinite recursion. The flag, which in this case is setting that default. So the first line of the method initializes A, and the next several lines of the method print out the string representation of self and the value of A. Then now comes the decision to recurse or not to recurse. So it depends on the recursive variable, its value. So if the recursion happens, it calls X without specifying a value for the recurse parameter. So that parameter will default to self. So when we call the self, X called itself here, at this point, the flag is false, or a recursion at this point is false. Yeah, so if it calls X without specifying a value for the recurse parameter, that parameter will default to false, and recursion won't happen the second time through. So the recursive call uses a different value for the value for a argument. Therefore, different information will be printed out during that call. But upon returning from the recursive call, that is just after at this point. So upon returning from the recursive call, we find that the value of A in this run of X hasn't changed. So it's original, yeah? In short, every call to X generates a new local scope, even though self doesn't change. Yeah, and the output, yeah, as you have seen in the terminal, how we will go. Oh, so there's a tip here. Instead of printing out the default string representation of an object, you can also use the object ID method to identify the object. To identify the object uniquely. So they're just saying if we now do, at this point we do, that object ID. Yeah, that's the only place you're calling stuff. version 2. Yeah, so you can see the object ID. Though we are changing scope, but self remains the same. Okay, so if this listing seems like the long way around to making the point that every object call has its own local scope, think of it as a template or model for the kinds of demonstrations you might try yourself as you develop an increasingly fine-grained sense of how scope and self work separately and together. So it's possible to do the opposite of what that listing demonstrates, namely to change self without entering a new local scope. Interesting. So this is accomplished with the instance eval and instance exec methods, which we'll look at later. Oh, so there's a way X can call itself and also change scope and self at the same time. So like variables, constants are governed by rules of scope. We'll look next at how those rules work. Yeah, I think we'll continue from scope and resolution of constants next time. Thank you, guys. Thank you,
Chemicals.
Sig. Thank you, Gary.
Yes.
Yes.
We started doing this book in February and we're in page 100 out of 500.
Hey.
So, with our machine learning, risk comprehension, and data science,
Hey.
we might finish this next year, July,
With the highest understanding.
with the highest understanding and all the machine learning capabilities. All right, bye, guys.
Okay, bye, guys.